Hi, I'm the Amateur Logician, and presently you are viewing the homepage of my website, amateurlogician.com. Today I want to show you my entry on John Stuart Mill's inductive methods. Now on the left, you will see the trivium logic. You can click that, or you can click this arrow and scroll down to find the entry on Mill's inductive methods. I'm just going to click on trivium logic and then scroll down, and you will see that there are 40 entries to this tutorial on traditional verbal style logic. I go quite in depth when it comes to many topics. There's a lot of philosophy here, philosophy of logic, many fallacies are covered, and so forth. Now, entry 33 is on Mill's inductive methods, and that's what we're going to talk about a little today. Now, John Stuart Mill's inductive methods include the method of agreement, method of difference, joint method of agreement and difference, method of residues, and method of concomitant variation. And I mentioned that you will find these methods even in old neo-scholastic textbooks on logic. Now, pretty much 99% of all introductory logic textbooks will include a section or two on Mill's inductive methods. They're very influential, and Mill definitely contributed to logic, but I also mentioned he made a lot of errors in logic as well, and he had, I think, an erroneous view of the syllogism, and I actually linked to a description of his error and a refutation of John Stuart Mill when it comes to deduction from one of my favorite textbooks in logic, namely Principles of Logic by George Hayward Joyce. And you can read that if you so desire, but I don't want to cover that presently. Presently, I do want to cover Mill's inductive methods. And we're thinking about seeking a cause. And I go through examples. I talk about the method of agreement, and I have a table giving an example of how this method works, and likewise with the method of difference, and the joint method of agreement and difference, and of residues, and concomitant variation. And I have an example dealing with physics. And I also have referenced a math textbook I actually used. I was a math major. We used, in one course I took, a first course in mathematical modeling textbook. It's a very basic book. It's actually surprisingly basic, but it's definitely a useful thing when it comes to applied mathematics. So let's start from the beginning, and I haven't really updated my website that much when it comes to new material. I want to do that. I also want to really design a traditional logic course very soon. I actually have made some lectures, but it does take time. So I'm definitely busy, not only with this project, but other projects I'm trying to balance, and of course work and so forth. But, okay. Now, John Stuart Mill wrote a book called A System of Logic, and I linked to it so you can just read it online. And definitely the most famous chapter, I think, today would be chapter 8. And that deals with the methods we're going to talk about. And he explored ways in which we can discover causes. And no logician today would claim Mill's methods are perfect or exhaustive. These methods can only yield probable, not certain results, but they're helpful. Okay. And I go into what a cause is, what an effect is, the difference between an independent variable and a dependent variable. I also mention, and a lot of people get this wrong, philosophy and physics does not study the same thing or in the same way. I once had a physics professor who was saying, well, philosophy, well, that's just everything. So when we're studying physics, we're studying philosophy. I'm like, no, we're not. Philosophy really thinks about ultimate causes, and physics thinks about secondary or proximate causes. They're not the same thing. They don't approach the world the same way. But anyways, I don't want to go on that tangent. It's kind of a pet peeve of mine. So let's start with the method of agreement. And with the method of agreement, we may be led to discover a single factor that's present among a number of separate circumstances, where all of those separate circumstances lead to a particular phenomena. This single factor, if found, will be a necessary condition. So here is an example I give of the method of agreement. So we have occurrences, and we have green beans, eggs, carrots, tomatoes, nuts, and we have this phenomena of sneezing, swollen eyes, and lips. Okay, so let's say you have an allergy. Let's just pretend this. And you show these symptoms, right? Of sneezing, the swollen lips, the swollen eyes. And your diet is radically simple. We record what you ate and didn't. And for each occurrence where certain food was absent, we disregard that food as a necessary condition for that allergy. So hence, for example, occurrence number 1 did not have green beans, but because the phenomenon occurred, green beans cannot be a necessary condition, right? And looking through the data, eggs, right, are present in each case, okay? So they're present in case 1, 2, 3, and 4, and that means eggs are a probable cause of the apparent allergy. We can't say for sure, okay? Now recall that Q is necessary for P when if P is present, then Q is present. So think of it this way, if the phenomenon occurs, then there are eggs. Now, as far as the method of agreement goes, it's not a bad way to engage in inductive reasoning. It just has to be used with great care. Maybe there's another factor that you somehow neglected, and that was present in each occurrence. Okay? Perhaps each time you ate near a pet, for example. Maybe the pet is causing the phenomenon, not the eggs. And another thing we should say about this type of method is that even to construct that table requires an intuition about what to record and not to record. It takes some understanding of what can be causally relevant and what can't be, right? There might as well be theoretically an infinite number of possible necessary conditions. It would be impossible in practice to eliminate all but one. Moreover, some factors might always be associated with the phenomenon but not causally related. A relationship between things doesn't automatically imply that one thing must be the cause of the other. But we can see why, as a rule, if we're careful, that the method of agreement can help find a probable cause in terms of, okay, we have this allergy, what is it? And the simple diet is helping us determine what's the probable cause. Now, the method of difference is the next thing to consider. And I quote, by the way, John Stuart Mill directly, okay, from his textbook. Now, Mill notes that these methods are based on elimination. So in the method of agreement, we disregard circumstances to finally arrive at the circumstance that suggests a possible answer. The same thing basically happens with the method of difference. Presently, we're looking for a sufficient condition. So if we're thinking about if P then Q, remember P is sufficient for Q, Q is necessary for P. If we think about the antecedent and the consequent. Okay, and that's a big topic I keep on hammering that I think a lot of textbooks don't when it comes to what is a conditional when we say if P then Q. So presently we're looking for a sufficient condition. We compare two occurrences, look for what they don't have in common. Each occurrence has almost everything in common. The goal is to find a connection where 1, its presence is associated with the phenomenon, and 2, its absence is associated with the absence of the phenomena. So here's the example. So we have occurrence 1, occurrence 2. Again, we have egg, sugar, this time vanilla extract, peanut butter, nuts, and the phenomena. Okay. Oh, we're doing something different in this. Okay. I haven't looked at this. I wrote this, I think, almost a year ago, amazingly enough. Okay, so let's pretend we're making a dish together. It's a dessert to satisfy our sweet tooths. We make the two dishes. We make the dishes 2 times, I should say. The first time it had sugar, but the second time, due to my stupidity, it had no sugar. A condition is not sufficient for the phenomenon being sweet if it is present when the phenomenon is absent. Okay, so we see that in occurrence 2, the sugar is absent, it's not sweet, whereas in occurrence 1, it's present and it is sweet. Considering what it takes for the dish to be sweet, we must disregard each food as a sufficient condition if it's present when the phenomenon is absent. Hence, occurrence number 2 reveals to us that we should disregard eggs, vanilla extract, peanut butter, and nuts. Looking through the data, only sugar is absent makes it not sweet. Hence, sugar is the probable cause for it being sweet. This example is rather simplistic, admittedly, right? We should all admit that a more complicated situation like this could be of great aid to a chef. Still, this method has to be used with great care. It is based on the different occurrences being identical save one factor. That's impossible in practice. The trick is to make sure any differences are insignificant, though determining that is a matter of intuition. While this method searches for the presence of something to be a cause, it may also be that it is the absence of something that is relevant. Now, the joint method of agreement of difference, we're basically combining the two. So combining the two previous methods result in an attempt to find a condition as both necessary and sufficient. We can start with the method of agreement to find a probable cause. To increase its likelihood to be a cause, we then try the method of difference. We'll 1. Find out if there is a single condition present in at least 2 occurrences when the phenomenon is present, and 2. Find out if the single condition is absent in at least 2 occurrences when the phenomenon is absent. And I give an example. This time, let's return to our first example. What can we do to increase the odds that eggs are the culprit? Okay, so here we have that table. So the method of agreement suggests that eggs are the culprit. To increase the odd, let's now apply the method of difference. So we have occurrence number 1, and I have 1 prime. Okay, so we see that. Okay, so with occurrence 1, we see eggs are present, and let's see, green beans are absent, carrots are present, tomatoes are present, nuts are present, and when the eggs are present, we have that phenomena, right? But once we take the eggs out, other things being equal, right? So we still leave out the green beans, we keep the carrots, we keep the tomatoes, we keep the nuts. We see the phenomenon is absent. With number 2, same kind of thing. Eggs are present, the phenomenon is present, but once we take the eggs out, the phenomenon is absent. Same thing with number 3. The eggs are present, okay? The phenomenon is present. We take the eggs out, it's absent, the phenomenon is absent. Same thing with 4. So now we've definitely increased the odds, right? You ran an experiment, each occurrence was redone, but without eggs present. Okay. So compare the difference between number 1 and number 1 prime, likewise with number 2 and number 2 prime, etc. Hence, eggs are a probable cause of the apparent allergy. Okay. So we're just combining the two, and we can see that definitely increases the likelihood that we found the issue. Then the method of residues. There are knowns and an unknown. The method of residues seeks the unknown. A range of effects is produced by several causes collectively. We know those several causes. All those causes, save one, we know their associated effects. The remaining effect, not accounted by those known causes, must thereby be caused by the remaining cause. So I have this kind of rough symbolic illustration of this. So 1, A, B, C, capital A, capital B, capital C, leads to A, B, C, lowercase. That big A leads to little a, big B leads to little b, so it seems plausible to say big C leads to little c. We might have 3 causes working together, A, B, and C, and we have 3 effects, little a, little b, and little c. We know that big A causes the effect little a, and that big B causes the effect little b. Given all this, since big ABC causes the effect small abc, it's probably the case that big C causes little c. And a lot of logic textbooks give mathematical examples. I don't think the examples they give are quite interesting or good, because I've seen examples very much like this used like in Patrick Hurley's textbook, which is a contemporary textbook that's often assigned. But I think a much more interesting example and very complex mathematically concerns the planet Neptune. Its existence was mathematically predicted by the residuary phenomena from the motions of Uranus. So it used like this kind of reasoning here, right? But with much more sophisticated mathematics than the example that you often find in a introductory logic textbook. Okay, so that method does show up, but um, okay, just to give the simple example, this is what a lot of textbooks give. Like if a plus b plus c equals the net effect, and we know the net effect a and b, then we can solve for c. So pretend we have an 80,000 pound loaded truck. When that same truck is unloaded, weighs 35,000, is carrying goods to Walmart. How much do those goods weigh? Well, obviously that's just an algebra problem. Okay, but it's modeled with this method of residues. But the interesting example, like I said, is actually the prediction that Neptune exists based on the motions of Uranus. They were able to infer that, okay, something is happening here based on its orbit, that something's pulling it, so to speak, and affecting its orbit, so there must be this another planet. And that prediction turned out to be true. Then we have the method of concomitant variation. Concomitant variation. I'm having some difficulty pronouncing that right now. Okay, so a changing value of x may be followed by a changing value of y. So it might be that x is the cause and y is its effect. That causes the independent variable that results in change in the dependent variable. Something increases in strength, for example. Another thing, as a result, increases in strength. Or maybe if something increases in strength, another thing, as a result, decreases in strength. Okay. And mathematical modeling often deals with these types of issues. We're thinking about something directly proportional or inversely proportional. And there are a lot of examples of this. And I go through Ohm's law, that we could, so to speak, kind of derive it by this kind of this experiment, okay, the simulator. So I link to it, and you can play with it. So this was developed by the University of Colorado, and it's pretty cool. So you have this interactive virtual laboratory, so to speak, and with it, I kind of construct an experiment to derive Ohm's law. Okay. So this is an example of an entry I have on my website. I think you might enjoy this type of material, and I hope people actually learn from it. But I think this is a pretty good example of what you can find on my website. And we've been talking a lot about induction lately on my YouTube channel, so I thought I would cover the entry on John Stuart Mill's method of induction and show you the entry on my website, on my YouTube channel. If you enjoy this type of material, please, hey, you can buy the Amateur Logician a cup of coffee. That would support my work. I would appreciate it. It also encourages me to actually say, hey, maybe this is a worthwhile project. I am very slowly developing a traditional logic course. I've created maybe about 10 lectures so far. I still have more work to do, but I am slowly constructing and creating that course, and I'm going to actually sell it in this case. I hope there is some demand for it. It's not just going to be based on the tutorial I created. It's going to include new stuff and exercises and all the rest of it. And of course, you can also get the newsletter at my website. It's for free. I don't send out many messages, but occasionally I do send out updates, and I definitely will send out updates when I get that logic course complete and I upload it and so forth. But anyways, thanks for watching. I appreciate your support, and I'll see you again soon, I hope. Bye for now.